show of hands if you'd like another moment to finish reflecting on this. Just take another few seconds here to give you a chance to think about yourself as a mathematician. Just make sure you thought about the habits of mind on page 12 as well as the habits of interaction on page 13. I'm going to have you check in with your partner in just a moment. I just wanted to be really transparent and call out that the purpose in coming back to these habits of mind and habits of interaction and really pressing that we're making sense of them and that we help students make sense of them is that they are a tool for helping the kids to achieve in the Common Core state standards, specifically around the mathematical practice, but and also in the content standards. Because as we do math in the way that the standards for mathematical practice are calling out, that will help us with our understanding and with their achievement. So if you would just turn and tell your partner, what's a habit that supported you in the work that we just did together? And what might a habit be that you want to work on? Okay? So what's a habit that supported you and what's a habit that you would want to work on?
What's the original question that we were asking when you're using math in your everyday life?
Yeah, as a mathematician, so not necessarily as a teacher.
Because I'm a teacher, and I was thinking about, so I didn't rate myself, I feel like.
Well, and I would apologize, so that wasn't
Because
clear.
then the question just asked us to talk about self-different than assess, and I was originally self-assessing on self, so I just looking at this as a picture.
Using math or
So we'll go back and forth between
I think more about this as the old teacher.
I think this one would be work out for sure. I got it.
Yeah, I did that still. I'm wrapping all this stuff. To get to
No, but like today, I had some questions today.
Little.
The right answer to teacher.
I'm going to increase this perseverance then. How might using some of these habits and the types of problems help support this perseverance? So you're building up that endurance.
Right, yeah, just a lot of it's just been questioned, just being able to question better and being able to
So task, Emma.
hold them out.
Yeah. Oh,
She is comparing, kind of like this compared.
The one, I guess I guess it's more of a teacher. A lot.
They want to talk about that early in the morning. You know, sometimes she's trying to do all these things. Or draws.
Yeah. I think it's now getting to the point.
Yeah.
How much damage is
So,
done?
Yeah, exactly.
You know, how much power.
what's your degree in? Is it special?
Went out for 3 hours. And 12 hours.
right. I'm going to draw us back together if I could.
It's unfortunate that way.
Thank you. So again, I appreciate the sharing that you're doing and, thinking about yourself as a mathematician as well as yourself as a teacher. So the original question was about, yourself as a mathematician, and if that didn't resonate quite right, I apologize. You could certainly be thinking about yourself as a teacher as well, because sometimes it's hard to separate those two roles. Want to point you towards a little bit of research that might support some of what we're thinking about right here. Yeah, absolutely.
Laura, can I just ask a quick question?
Sure.
Because the first time we went through this training, we got these notebooks. And I know the self-assessment that you just had the teachers do, the title on it was Student Reflection Tool.
Yeah,
And
it
so
still
the
is.
right. And so one of the questions I have, because I know when we first went through this training, we got a notebook with a lot of these tools, and we tried to And then I tried to intentionally put some out for teachers to use and whatnot. And I didn't necessarily see them being used in the classroom. And I think my experience has told me that unless there's a sense of deep understanding or purposefulness of why would I use this and when would I use this and how's it going to benefit me, why am I going to take the class time to do it, that is probably not going to be. So my question is, with that tool that you just had the teachers reflect on, when would they use that with students? How often would they use that for students, and how would they make that decision?
Anybody want to chime in before I say something? How might you use that tool with students, and when might you use that tool with students? How often?
And I might even have a different question, is as you did that student reflection, did it occur to any of you, did you like, oh, I could use this with my kids here? Was that an automatic transfer that you made when you did that reflection tool, that this would be a tool you'd use with your kids?
I think the times from that first training, you're right, I didn't use it with the kids. I tried it once and I didn't get the kind of feedback I was looking for. What gave me better feedback was doing what you do. By having it up on the wall and referring to it as a class discussion at either at the end of the period or that's when I got the most from it.
The only thing I'm pulling out is that this here, the visual for, for kids to identify even maybe during the lesson, hey,
Or,
stick me
yeah.
on, we've made sense of, I don't know, that to me,
Where the power in this comes from, if all that stuff's embedded in your lesson.
Yeah.
And these forms of kids putting 1s through 4s, which are subjective anyway, I don't think that gives you the feedback as if you structure that into your lesson, ask kids to point out what they see and turn and talk about it is more powerful than these. It's just a waste of paper, really, because it's in the moment of the lesson, I think. I don't know.
And part of what I'm struggling with is we're also working with success criteria for the kids to be able to use as a resource. And I know for that, if I hand them the little laser and let them point at the one that they're talking about to help with that encourages them to look there. I don't want to give,
Too much.
you've got every day the success criteria and then you're adding this on top of it. I don't know, to be honest with you.
I think
How
that's
much-
embedded in your success criteria, I
But I see
think
what
you
Matt's
marry
saying.
them together.
Yeah, I see what
you
you're
know.
saying, because you got your target, your success criteria, your best practices,
I mean,
and then
yeah,
you're
there's-
on top of this.
So I see
But
the
I think
value
where-
of these, and I see them explaining how or what they're using in these. I get that. It's just,
You gotta make it meaningful, like,
you're
your
like, how much are we gonna give them in a 50-minute period?
dissect it.
So a couple of things here. So I want us to think about those tools and whether you would use them in your classroom, and whether you would use it in its entirety or whether you might use parts of it. So I think about what the question's asking of kids. It's asking them to reflect on the habits, and it's asking them for some evidence of the habit. So it could be that you're not using that specific tool, but you're doing
Yeah.
what that tool is asking of
Yeah.
kids.
I see that.
So again, thinking about the importance of reflecting, and then thinking about the importance of being able to connect some evidence to that reflection. So keep those ideas in mind, because I think that that's a really important question to ask, whether it's this tool or not. How are you going to help kids engage in the mathematical habits? So I just want to point you towards a piece of research, and then that's essentially a question we're going to do some brainstorming around. So on page 26, and I would encourage you to grab a sticky out of one of the bags in your note and just flag page 26, because there's a few different pieces of research around reflection and metacognition, why it's important. Okay? But what I really want us to think about is, how do we foster that student reflection in our classrooms, which is exactly what the student reflection tools are all about, whether you use the page 12 or 13 or whether it's around the habits that are up there. If you would grab your important moments, so you're going to flag page 26, there's some research there to come back to, and then if you would grab your important moments, if you want to pop that out. And someplace on your important moments, it could be the front, it could be the back, wherever you've got a little bit of space, make a note called Fostering Student Reflection. Okay? So somewhere on there, title it Fostering Student Reflection, wherever you have a little bit of room. Okay? And again, if you like the tools on page 12 and 13 as a way to support students in reflecting on their use of the habits and the evidence that is coming from that use. That's fantastic. Write it down as one idea. But what I want us to do is to brainstorm how else can you get kids to engage in the mathematical habits of mind and habits of interaction other than that tool. You've seen me do a couple of things, point to, touch the habits, put stickies on it, ask you which ones you've used. So you've seen me do a few things, but those are by far not the only ways to do it as well. So I'm going to ask you to get up and move in just a moment. We're going to get into actually groups of 3s, but I want you to be with people that are not at your current table.
So when we're talking about those reflections, all those are embedded in every lesson, or is there like certain lessons? I know that I've asked somebody this question before, but like, can you focus on a certain one or two?
So I think you can certainly highlight, one that you're specifically working on with the kids in that particular lesson. My encouragement would be that you put them all up because they're kind of a package. It's really hard to do any one of those in isolation of others. So that
Okay,
isn't
so you can't
necess-
say like today we're going to persevere and seek more, so that's what our lesson focus is. What you're going to say is you're going to be doing all that, but if you wanted to.
Yeah, so you could certainly say to the kids, okay, our emphasis today is I really want you to persevere and seek more. And that might be the one that you ask them for evidence about in the lesson. You don't necessarily have to ask for evidence for all of them every time. My press would be that it's hard to do that persevere and seek more without having engaged in some of the other habits. So whether you call it out or not, totally up to you. But I would encourage you to put them all up so that kids know that these collectively are how we're doing things. So let's do this. I'm going to have you stand up and find, let's just count off. Let's do 1, 2, 3. 1, 2, 3. We're going to slide you into a group in just a minute. And then 1, 2, 3. Okay? So I'm going to have the 1s get together, the 2s get together, the 3s to get together. And which number would you like to be?
Oh, good, 'cause I always let the album
Nope.
choose. I'm going right here.
Okay, perfect. Okay. So the 1s get together, the 2s get together, the 3s get together, and Renee, you get to pick.
Where are the 3s over here?
Do we need to bring anything with us?
Your important moments so that you can write on it. Okay. And what I'm going to ask you to do with your trio or quad, in one case,
You guys 3, ladies?
is think about how could you get kids to engage in the mathematical habits of mind and habits of interaction. What are those ideas that you can come up with together?
I'm a 3.
Oh, you're good.
One's transferred back over here.
Okay, then you're 3, I'll do 2. I'll take 2.
She went 1, 2, 3.
You're the better half. You're the other Dan I've been looking for.
Yeah. Oh yeah. There we go. I'll be Dan's other brother, Dan. Wait for Dan's other brother, Dan.
Productively use the
I think they said whoever doesn't have a beard is leading this group discussion. And that no goes.
So how can
He's been training for it.
Share your ideas for ways you could promote mathematically.
First of all, I gotta get the
Yeah, well, there is a whole system right there.
Right.
Holy moly.
Modeling. Right.
One.
And then I agree with you, it's like how well as the lesson
It's just constant.
geared around modeling that thing, or is it
Being aware.
bring it up
Yeah,
and
these
aware?
3 things that are right here.
It's kind of like
Yeah,
situation,
yeah, point
here it
out
is, like, okay,
specifically
now,
when, blah,
what
blah,
do you
blah,
say?
and ask students to identify.
No, I was just asking if you do
habit of mind.
every single one of those in every lesson, or
Yeah, I think it's just,
or is there like
I'm checking it out. I mean, you have to be intentional. But I don't think you can just go, the whole lesson today is gonna be,
Add some of those.
And you don't
could,
want
but it seems like it's more situational.
He said, all right,
Probably start
you two guys real quick. What would you do if we did today?
a week or once you
Share it out afterward, talk about everything.
and then you'll see you can start to have
Kind of like a diet, you know. Part fraternity talk, pinpoint it, you think we covered today, and then
Staff
we
and
can grab a
but
group,
what
share
you
out,
don't
and
mention was
monitor
be a
it, and
mistake.
You might not know which ones are actually.
just to show what kind of teaching took place in class that day.
Why do I care?
Yeah.
It's like,
One
Maybe
thing.
just my tally.
Sticky note tally.
Based on
But
the
if the thing was,
type of thinking you need.
so am I more concerned with how they're thinking or am I
Or
concerned
engagement in the
with
habits.
the success criteria that they're using to?
So if you're hearing an idea come up in your group that you think you
Because
might
if you
want to
need,
try on,
if you need them to come up with a model along with their math, they have to have mathematical representations to go along with your division as well.
I think you probably have to show what each one looks like what does persevering look like, what does.
That's about a 1, 2, 3, 4.
Because that's the whole reading program right here.
Or you could do
That's what I have, like, I have the other conversations. So here's what they need, habits and mindsets and starters.
If you didn't do that, you wouldn't.
So they are, in reality, connected practice.
So, higher level.
Yeah.
And I think the more
The success criteria breaks down these.
Or,
So are you guys doing that?
genuine questions are like,
Having kids?
so you start a genuine question before they come in and they answer it. So, what
That's
do you think
trying
about
to focus,
blah, blah,
trying
blah?
to.
Or, I noticed
See, I'm
that.
trying to be visual.
Last year was just
The
learning.
first part for them.
Yeah.
Now we're breaking
And
down
it's
the
just
learning.
visual, so it's really
Success
candid.
criteria
They're
for that
like, what? And
specific
then they
lesson.
ask a genuine question, because they have a hard time coming up with those themselves. And so then if you know your lesson and you know your concept, you
I
can phrase those to get where you want to get.
It's kind of
You know,
interesting because
especially the younger the kids.
I thought that high school would be more, like they'd be chatting more, but actually my algebra 2 class, that's when
Anyway,
we
this is
discussed
familiar
but
Started
it's
off
just
with
because last year I had kids that were coming like from years, 2 years,
There's a lot of
and you guys had them going like that, so it was just really easy. Whereas this year, it's just like, I don't know, I guess, they had a bunch of different features
So
before,
it was more
but it wasn't
situational,
instilled in them.
wasn't it? Just say,
high school.
Of course.
She didn't go through every one of them first. She just, as we came up, she said, here's.
Yeah. Yeah.
About it, middle school, still acceptable.
So yeah, it's not, like, it's really easy. And then some of the stuff I'm teaching is difficult, and I just need to show it. So it's a lot different than last year.
And what I did with these before, I put them all on my wall, and I going really get one improvement. That's what, like I was saying, the best practices, you know, on top of doing this. Basically what I'm doing now is doing the lesson and then referring it back to the best practice, like, you know, making sense of it.
Describe that.
And this is kind of, but I also do, you know, mathematical representation is just more than that. To me, it's the same thing.
And that's when you go to plan your lesson.
That's the best practice.
Okay. No, will you speak for a group then?
You sound like you're ready to present for us.
See, that's.
Thank you very much.
So I was the slowest one.
You
wanna speak it? You wanna speak it?
Well, you've been introduced to know those goals.
That's the whole.
Absolutely.
All right, let's
So
go back.
I do have to say that in my classroom, the kids would do that. Whoever did that first.
Would be the
Oh,
one.
yeah,
Yeah.
absolutely. Because they were trying to get out of it.
You want to speak? Perfect, you're volunteering.
Or you would say something.
It really is.
I agree.
Yeah, I saw that.
Well,
I know, I
It's
like
easier
quick.
to
Let me look at
Well, it's
it.
easy to talk
Where is
about.
this?
Oh,
Saw
yeah.
that. It was like,
yeah, and so
All
this is
right.
education or somebody else.
I'm gonna pull this back together real quick. So you probably will hear me say this from time to time. I get this privilege of eavesdropping or even, you know, joining into conversations from time to time. And I really want to make sure that you guys hear what's happening across the room. So I'm just going to have us whip around the room and maybe go around twice and share an idea that you and your group came up with. Okay, I'm laughing. So I was over at this group and I was just telling them that
Who was first?
Quick again.
this, the no-nose piece, that's been around a while, and I would have kids do that in my classroom, and whoever got their finger up there first actually got to be the one to report out. So,
Dan was.
but there's some really nice,
Bait and switch.
There's some really nice ideas coming out here. So if you hear, somebody in another group say something, you're thinking, oh, I might go try that, or that sounds like it would be really easy to go and do, but powerful for students. Jot it down. I don't know about you guys, but for me, teaching is often beg, borrow, steal. So I'm gonna listen to what you guys are saying, and I'm gonna take that idea and I'm gonna go use it. Okay. But let's actually, I'm gonna start over here with this group.
Go ahead.
They try to nominate me as a spokesperson.
Our group leader. There we go. Laura.
So I'm gonna decline.
Okay. Yeah.
And I'm gonna let you guys have that opportunity.
Well, obviously, we talked about we need to first get the posters,
Okay.
and then,
So having the posters is a big deal,
right,
and getting them up.
yeah, and then, is that enough?
No, do you want to, let's add something else.
yes.
That's kind of a given.
See ya.
Good try though. So once you've got the posters and you've hung them up, what are you gonna do with them so that they're not just pretty pictures on the wall?
And we talked about how it's gotta be kind of situational, when you see, just like we're doing here, when it's happening, you need to actually do and mention it and address it, and not, because Jason asked you the question, you just go through all of this stuff and teach all of this stuff, but no, making it more situational where it makes sense that this is what it looks like to make sense of a problem or whatever.
Absolutely, so calling out when it's happening.
Exactly.
I mean, you could go through and explain to your kids what each of those means. So that might be a little dull if it's not wrapped in the context of actually doing some math together. So, I mean, you could, but I think that it might be powerful to have you call it out or have the kids call it out when it's happening. Yeah, with this group. What's something that you guys were thinking about?
Well, one thing that just popped in my head was, with like the 4D training stuff we're going through as well. And one of the things we've been intentional about is 6th grade level introduces a lot of these concepts. 7th grade level, we kind of refine it, and hopefully by the time they've hit 8th grade, they're very familiar with all this stuff.
Yep.
And I can see this falling right into that as well, where as long as we're all doing it grade level by grade level, it becomes just the common verbiage that you use in your math class every day.
Absolutely. So year one, it might mean that everybody's having to do a little more work to build up this understanding. But after a couple of years, your 8th graders will be coming in using that language.
Right.
Yeah, absolutely. Absolutely.
That's why you got the highest marks in our school. You only got 4 Ds, we all got 5 Ds.
5D plus, baby.
You got 4, we got 5.
He passed his class.
We've got 5D plus.
That's awesome.
Yeah, exactly. We gotta get the 5th dimension.
I'm wondering which one he left off. Maybe purpose.
Rebecca, what was something that you and your group were talking about?
I definitely see just embedding these into my success criteria and then just choosing one of them to do a reflective activity about, not all of them, but just marrying them together. I see myself doing that. Another thing that I talked about too is, especially for 6th grade, is you have to use sentence stems. So you have to take these practices in their discussion and you have to sentence stem it. So start like with a genuine question. Start the genuine question. It's basically a fill-in for them so that everybody's asking it. So those are a couple of things that thought.
So two really important ideas. One, embedding them right into your success criteria or into your learning target. And then providing sentence stems that help kids talk in the way that we want them to talk and or to be able to use the habits in the way you want them to use. Yeah. So let's just go backwards this way. So what's the second idea from you guys?
Tied to the 5th D.
So some of your ideas have come out.
Get some mileage out of
You
it.
guys have an idea that hasn't come out that you want to share?
I don't think so. It was pretty much mainly just addressing our main idea, I guess, was just addressing within our units, our lecture currently going on. Like I said, like we could, being that if we implement it and it's unfamiliar, just hold a typical day or a week or a unit, and then whenever it arises, say, hey, see, we are doing these, we are using these things, and you're familiar with them, you just haven't been taught them, so continue to do what you're doing.
And I had shared with this group on the end that I had the privilege of being in a third grade classroom not too long ago where these were brand new. The teacher had hung them up, but they hadn't had any conversation. So imagine third grade classroom. She taught a lesson. At the end of the lesson, she asked the kids, much like I asked you guys, but she asked her third graders, which of these habits have you been using? And the kids were able to talk about it. There was a few words up there that they needed to have the teacher read to them because there was a couple of words that were unfamiliar to them. But as they started to talk about how they had been thinking with each other and how they'd been thinking in the classroom, they were able to talk about a lot of those habits. And then in a few places, she put words to it. So she had students say, well, we were drawing pictures of the math. And she said, oh, we were also, we might call that a representation. So she did put, a couple of words to that. But just think about, kids are really pretty good at picking up on these habits. So not necessarily saying that you should put them up and not refer to them, but if you put them up one day, point them out. Say to the kids, we've got some new habits up here. At the end of the class, I'm going to ask you about them. See what happens. See what they're able to say to you at the end of the class, if that's the reference. And then you start calling out, either the evidence or naming things if you need to, but you get some formative information about where kids are to start with. Then you might choose to then dig into one or the other of the habits for a specific lesson. I heard that idea coming out. Yeah.
When we did this the first time, Tim Nelson and I were working together. It was something similar to these, and it had all the same kind of ideas, but we ended up making for their student-led conferences.
Yeah.
Where they picked the one that they felt that they were doing most productively in their own math and present that to their parents.
Nice.
And all of them had something different. They weren't all, like every single one of them could make connections. Every single one could, but some of them were definitely better, at others, and they felt that way about themselves. But that's something I need to share.
And that's really powerful when they can start to talk about it with their parents or with with somebody else, what they're doing. You also get some formative information from listening to that conversation. How are they making sense of this? An example that I've heard come up in other trainings, and if you like it, use it, and if you don't, that's okay. But you've mentioned having kids call out evidence for a few of them. I've also seen teachers use or put one question like on an exit ticket or an exit task, if they were going to use that, ask something about the math, and then they'll ask one question about one of the habits that they're really trying to pull forward. And then you get some written evidence so you can kind of look at it. And then one teacher in particular that I know was doing this would then take what the kids had written and go back into the class the next day and share a couple of the statements and ask them how that was providing evidence for the habits, especially if it was something that they were really trying to get the kids to dig into or they weren't sure the kids had solid understanding around. So just one more example.
So something that I'm thinking about is trying to connect this to the work that we've been doing in the two middle schools with 5D over the past couple of years. I know both middle schools.
You said to get that out there.
She's
We are
making sure
with the 5D.
she knows it's 5D, not you. She does.
Most of them.
Yeah.
I know schools have looked at student engagement, and one of the strategies for student engagement is raising the cognitive level of the task. And then I think both schools have worked with that depth of knowledge chart. So, if you look up there and justify and generalize, those words are on the depth of knowledge chart. So it just made me wonder, could you embed it in your target and task and just tell kids at the beginning, today we're going to work on justifying. I want you to just be kind of taking a mental note or jot a note when you see us doing this. And then maybe debrief it at the end and structure the task so that it was part of the task. Because that would get at a couple things that we've been trying to work on that are connected to this.
Absolutely. And I think it's really important to call out those connections to the 5D so that as we're working on this today and tomorrow, be thinking about some of those moves that we might be making here or that you're going to go back to your room and move or make, and think about how they overlay with the 5D around student engagement, around classroom culture, around pedagogy, around formative assessment. Where might some of these specific moves not only be coming out of research around how students learn mathematics, but would also provide evidence to someone in your room that you're engaging in the moves that 5D is asking you to make. So hopefully you're not seeing these as all these separate things with Common Core over here and now best practices over here and 5D over here, but really just really layered on top of each other. And it's also kind of getting like a threefer. When I do one of these things, I'm supporting my students in that deep understanding around the Common Core and the standards for mathematical practice. I'm doing things that are out of research showing how students learn mathematics, but I'm also providing evidence for administrative evaluation that what I'm doing is coming out of that same body of research.
Well, I'm just trying to think of, heard what Matt said about trying to juggle all these different things at the same time. So how can we make it part of the work that we're already doing without having to go, have the kids take down yet more evidence? I almost wonder if they could do it informally and there could just be a full class reflection for a minute or two at the end.
Absolutely. Absolutely. So whether it's there or whether you capture it on an exit ticket and then think about it, it all depends on where you are and what kind of data you're trying to collect from your kids. Other final thoughts on that? Any other ideas that we didn't hit? Okay, so I'm thinking this might be a good spot to break for lunch. You guys ready to get up and move around a little bit? So it's 25 after. Well, can we just come back at noon? Take 35 minutes? Okay, and we'll just start back up right at.
I have some business math classes, but
All right, I'm going to jump in here and pull us back together. Hope you had a good lunch. Chance to grab something to eat as you get outside in the sunshine a little bit. You gotta take advantage of that before our rain rolls in. I'm going to ask you to turn to page 28 in your notebook. And there's a couple of key ideas there related to conceptual understanding. Give you a couple minutes here to read. It might be that you're underlining, it might be that you're highlighting. There's some highlighters in those bags on the tables if that works better for you than underlining. But if you would take just a couple of minutes to read page 28 and highlight key ideas or look-fors in terms of what is the importance of conceptual understanding and why do we need it? So as you're reading, kind of keep those questions in mind. What is the importance of conceptual understanding and why do we need it?
You're late.
Well, Mike Nelson is.
Oh, yeah. The Mike Nelson
You
excuse.
could've wrote me in.
Sorry, I already used that one.
He's right there.
share with them what you were pulling out of page 28 that's related to the importance of conceptual understanding and why we might need it.
Yeah, I was just thinking about the training we did with Crystal this year. With when we talked about conceptual understanding, procedural fluency and application. I'll link in a couple things back to that. It really,
How,
it's a foundational thing, that works hand in hand with those skills, necessary skills.
I'm sure, concepts and how these fit
And
into
that's
the
where I-
it's hard when,
certain way,
Of course.
one that goes deep,
I
one that
think it's obvious,
and then I bring them all together. Where you start to figure out,
Yeah.
conceptually, they're just something,
Sometimes you don't have to.
so then you can build.
Yeah.
Having them fully understand.
And then the other thing is, when it comes to getting them directed, it's like, you're not going to do this.
Yeah.
You're not trying to get.
No, yeah.
You're actually, this is really good, it's building
Quality of being successful. Anything you try to do. That's kind of what
And then
my.
they
Yeah.
read more about like,
Yeah.
Yeah, just jump on the table. Jump on the table. Oh, I'm sorry. I did good.
A common core. It's really doing it in terms of,
Take about one more minute with your partner or partners.
I like the productive struggle comes from solving problems that are within reach. That part.
Yeah. Yeah, like the struggling doesn't mean that the frustration is extreme of a challenge.
It's reachable. It's not easily.
yeah.
Again,
Yeah.
To help them.
It's right in here.
You're not gonna give them the answer, you're gonna help them.
That's why I was thinking, that's why I don't roll down very well now.
Yeah. Yeah.
What do you think?
Alright, I'm gonna jump in here and pull us back together, please. So I want us to think about the importance of conceptual understanding as we do a little digging into a piece of the Common Core standards. So I'm going to ask you to turn to page 11. So keep that conceptual understanding ideas alive. Turn to page 11 in your notebook. And I'm going to ask you to read the chunk on page 11 about making sense. And I'm going to ask you to put that side by side with your standards for mathematical practice. And if you were to go to your reading section, that's the second section in the notebook, when we divided it up this morning with the purple pieces of paper, the standards for mathematical practice are almost to the end of the reading section. Okay, so they're not the very last page, but the two before that. And if it's helpful, feel free to pop those out, because you can always slide them back in there in a little bit. If you've got your own standards, that's fantastic. But if you need a copy of them, almost at the end of the reading section.
And it's called math.
Standards for mathematical practice.
Page 6.
So I'm going to ask you to read standard number 1 about make sense of problems and persevere in solving them. So you're reading make sense on page 11, and then reading standard number 1 in the standards for mathematical practice. if you're thinking about this as yourself as a mathematician, and make sense in the work that we did this morning, make sense of problems and persevere in solving them. So how did using the habits support you in achieving that standard? You could also think about it through the lens of being a teacher. How might engaging in the habits of mind and habits of interaction support students in achieving that particular standard? So you can take either lens that works for you in your conversation. And I'll let you check in with your partner or partners and think about those connections.
I like the first sentence in the art standards, it says they explain themselves in the meaning of everything. We talk about all the time. You gotta read this topic. You go to the store, real world, you buy 5 kids, maybe not even twice, maybe 3 or 4 times a year. You know, probably make $60.
Not like that, so like multiply it. It's all operation. Multiply it.
Yeah, that whole thing, yeah. That's like $500 in a single.
Metacognition about my answer.
How you work yourself through a problem. Yeah, because usually so. You take one of that.
What's an addition? Yeah. They're just talking about, so happy just to get numbers and then care about that. Friday had a hard time, like we were coming up with.
Yeah, exactly. And then you show them 2 different times. And then it really went on itself. And so it was going up by 1. Oh, the computer. Yeah, could get them like, yeah. I put it in the calculator, put it in, and it's wrong. Computer's wrong.
That is a big deal. Was that, students never asked that question. That's ridiculous answers.
That's one of the, that's one of the biggest, like, somebody had shown them like how they play.
Plug in this input, it doesn't work.
Starting with single step, simple
And
instructions.
what is it about this pattern that you're paying attention to? And how does that last one make
Originally had to check their answers, they had to plug it back into the original question. You have to do that by hand.
I can tell it's going back and forth.
Reaffirm your answers.
Really,
Oh, that's kind of incorrect. Well, then we can progress on
in light of some of the protocols.
students
The managed protocol that you learned previously here.
Plug that back in for your head.
Talk about
That rule was set. And I also have, that rule was set like.
in terms of
program we were
8
on.
and 10 persevering and so on. Hearing other people's ideas and working with really this should be shifted so
When I got here like 8,
you know, they don't understand the concept.
steps,
All
and
of
just
us
finding the common.
there are
Multiplying the reciprocal, multiplying critical counts, doing all that, those steps, and so me explaining that. You showed them, you went to the calculator, and you went to ABC button, that's what guess what, that's not. I can't test it, not proving something. I struggle with that because, I just wanted it for this, right, so like. Procedures are tracked.
Right.
All right, I'm going to jump in here and pull us back together.
Yeah.
So again, I mentioned this earlier, I get this privilege of eavesdropping on conversations, and I want you to hear some of the things that are being said around the room. But really thinking hard about, specifically, we were reading about Make Sense on page 11, and you were thinking about this first standard around making sense of problems and persevering through them. And then the question was just a little bit broader. How might engaging in the mathematical habits support kids in doing this? Either support you if you're thinking about yourself as a mathematician, or support students in the classroom. And Jason, I'm wondering if you would share what you were sharing with me when I walked by your table.
We were just in my class on Friday, we were coming up with an equation from a table. And I purposely, all the inputs were just going up by 1 except for the very last one that we did, and I changed it where the inputs were going up by 2. And the kids had talked about how they were coming up with the equation, because you know, some of them thought you just had to guess and check the whole time, but then we talked about the strategies they were coming up with, so then they came up with strategy. And then I think the outputs were going up by 4, so everybody said it was like 4x minus 4 was the actual equations in the table, but it was actually 2x minus 4 because of the inputs were going up by 2. But I think, and I let him just talk about it, and then finally one kid said, well, that doesn't work for one of the inputs. And they're like, what are you talking about? And he said, well, he inputted the number and it didn't come out. And they're like, oh, but that should be. And then they started, a couple kids started to see that they saw the pattern instead. So.
Yeah, so as I listened to you talk about that, I was thinking about that pattern piece. You know, what were they paying attention to? How were they making sense of that? And part of that was then that they had to persevere, or persevere depending on where we're pointing, to really think about why doesn't that original thought about the equation make sense? Absolutely. I'm going to hop over to the other side of the room. Will you share what you were talking about with your partner there?
Yeah, we talked about, there's a key line in here, reflection about relationships between their thinking and other mathematicians' ideas and how important that is in terms of meaning making, and how we've made a shift at EMS this year where we've pushed our special ed students into the gen ed setting as opposed to the other method where they were in an isolated class. And you know, just that exposure to new mathematical ideas really helps students evaluate their own ideas, and then you know they can change their thinking, and it just helps grow. And it was kind of the same thought we had several years ago where I had an 8th grade math class and an algebra class, and we had students in that 8th grade math class who were capable but were underperforming, and we found that when we had all the classes grouped as one, we no longer tracked those kids. You know, when they were exposed to those other ideas, they did step up and they did grow themselves. And so it just in terms of learning, you know, through the discussion protocols, getting that meaning making out publicly is really important.
Anybody want to respond to that idea? Something that you're thinking about that connects to it? Turn and tell your partner real quick. What's one thing that went through your mind when Will shared that? What's one thing you were thinking about?
Just more when you have a group working on the concept, the same concept. Forces different ideas to come in, especially if it's a problem that's a little bit tougher, you know, where they might not have the
Two classes.
Yeah, I think it's called mistakes and stuff. I think that hearing other people find their own mistakes. It's almost more powerful. Yeah.
All right, I'm going to pull this back together.
I kind of lost it.
Pull this back together real quick. Renee, would you share something that you and your partner were talking about?
Well, we were talking about what Will's comment was, right? So we were just, I was just commenting on how my classes are all different, so the combination of the students, you know, definitely, depending on the mixture, each class is its own.
Its own personality, yeah.
Its own needs.
Yep. And that we need to meet those needs of whatever students we have sitting in front of us at the time. Yeah, absolutely. Dan, will you share something that you and Will were talking about?
We're talking about, you know, when you have group activities where you have, say, one problem, and your table group of 4 is working on one problem. If it's a problem that's hard enough that they can't just come up with an answer right away, or it's multi-step, and they're forced to, really discuss and dive into it. All the different levels of that table end up rising up to the final understanding when they, hopefully through the discussions, come to an agreement on how to solve the problem. It's the same kind of format.
Nice. Matt, would you share something that your group was talking about?
Right? Too much.
3 pencils.
I'm down to 3Ds now. I got nothing.
Nothing? So a couple of things that, you want to add something on?
Yeah, just talking about those very classrooms that Will brought up. Even if the concept is flying over heads, if it's a safe place and everyone's willing to talk, and at least you get to see what wild misconceptions still prevail with some, and you get a lot of information.
Absolutely, so you get lots of formative information.
Yeah.
Yep.
Well, that was, Dan and I talked about that same thing too, about how that leads it. It used to be mistakes start new learning, but now it's mistakes and stuck points, and those misconceptions are a benchmark in time of where that student was at one point, and it's at least for, even if the student isn't aware of what they need to close the gap, that, gives those misconceptions give the teacher an idea of, okay, I know where they're at now, I have an idea of how to get them there. It's challenging though, it's.
So in small print on here, it does say new learning and new ways to reason. So that idea hasn't left. Yep, absolutely. You want to add something?
Well, we're talking about just the idea of persevering, and especially with our special ed math students. There's like an emotional maturity piece here that is often lacking in our students. And they, you make them go into a classroom and listen. That might help some, but if they don't have that willingness to persevere or haven't ever been taught to do that, then it's a little frustrating.
Yeah, so I think about, part of it is helping kids to develop these particular ways of interacting with mathematics and with each other, because they are life skills. So helping kids see when they are persevering and the benefits of seeking more around something. And I heard a couple people mention that might be able to look for some, where'd it go? Some comparing of different strategies that are coming out, so that if we have more than one out there, that kids can make sense between multiple strategies. And if a student doesn't have access to a problem, being able to then think about or make sense of some line of reasoning that's being put out there can be really beneficial to them in that making sense process. So even if it's not their idea, if it's an idea that's coming out, it gives them access to thinking about the mathematics. So we're going to continue to think about these pieces, and I want us to continue to think about that connection between the mathematical habits of mind and habits of interaction and the standards for mathematical practice. That when we help kids do these things, we get these as outcomes. So we're going to head back towards some mathematics together. So just real quickly, if you would turn to page 24. And there is a piece about the Common Core State Standards at the top and a piece about NCTM. If you would take just a minute to read down through page 24. And again, feel free to underline, highlight, or whatever is helpful to you. conceptual understanding, making some connections between those habits of mind and some of the common cores, the standards for mathematical practice. And then page 24 is really calling out some of the importance around understanding the various meanings of some of the operations across grade bands. So it's not just an elementary piece or a middle school piece or high school piece, but across grade bands. So I want us to think for just a few minutes here. We delved into 12 divided by 4. So I want us to think a little bit about 12 divided by 1/4. And you could do this on one of those 4-part charts if that is helpful to you, or you can do it on a piece of scratch paper. I've got blank paper up here if you'd like to have this blank paper to write on. I'll drop a few pieces off. But I want you to think about how could you visually model 12 divided by 1/4? What might your verbal description be? And can you come up with a context for that particular problem? I'm going to ask us to start with some private reasoning time. I think I should already have a piece of paper. I'm going to ask you to start with a little bit of private reasoning time first, and then we'll make sure that you have a chance to check in with your partners.
So do we do that on purple paper?
You could do this on purple paper if that's helpful to you. If you have a blank 4-part chart left in the notebook, you're certainly welcome to do that there. Some people have probably used them up by the time they went through all these pieces. So wherever you've got space to, if you've got a journal or notebook that you brought with you, you're welcome.
This is meant
Yes.
for this project.
Yeah, if that was helpful to you.
Thank you.
So let's start with some private reasoning time. Think about how you would create a visual representation, what your verbal description would be in an everyday life, and then we'll give you a chance to talk with a neighbor in just a moment. So I know not everybody is completely done thinking about this, and that's okay. I'm going to have you share with your partner in just a moment what you're thinking about related to this prompt. So if you have a complete idea, fantastic. If you're in the process of thinking about it, that's okay. Share where you are in that process of thinking about it. But try to be as specific as you can. Where in your visual that you're coming up with do you see 12 divided by 1/4? How would you describe it, and what might your everyday situation be to go along with that? I'm going to ask you to share with your partner in a listen and compare one more time. But I'm going to have partner B start this time. So I believe the Bs were sitting closer to the back of the room. So partner B, you're gonna have a little bit of time here to share. Partner A, you're listening to understand. We'll flip it around in just a moment so partner A gets to share, and then I will give you a chance to talk together about how your ideas are the same or different. Over here where we've got a trio, let's go A, B, C, and then I'll make sure that C gets an opportunity. So Jason can make sure he gets it. Okay, so partner B, I'm gonna have you start.
12 people, each size of 1,
Good job.
It's got a, but not how this. Times 12.
I don't know if it's fractions.
Quarters 12. Divided by 1.
So I started out as a kid working in okay, like I know what
Yeah,
it's
so
called.
Conceptually about this is that
So originally I told Thomas about the extra group, and so then I said,
and one fourth
turn
are in
each town
comparison
to
to the
4
same
parts,
whole.
or cut each town to a fourth,
So like in my
and then
mind.
cutting each one to a
Because
fourth,
you
and then
could
how many total parts are there?
I know.
Yeah.
This is in my mind.
Because you could say,
Well, no, this is,
I mean,
And every day last
so
week.
one idea I had is.
All right, partner B, finish your sentence.
I don't know.
Flip it around. Partner A, it's your turn to either make a connection to what you just heard or to share how you were thinking about it differently.
Show like exactly what four took 12 things and broke them four. So now we're breaking them down.
He was throwing apples earlier.
Then you have a fourth of a whole section, so they have to understand that this.
All right, partner
One fourth
A,
of
finish
one
your
of these
thought. Let you move into a conversation. How are your ideas the same or
What we're
different?
talking about here, because I can say, this is 1/4. How many of these 1/4s fill this?
And then resharpen that.
Spatial read.
How many mini golf pedals do you have now? Now we have enough for all four of my classes.
Yeah, yeah.
Which is just like if you did it this way and then had one, but then you
Twelve things divided into fourths.
So is that your?
Is that you? I mean,
how many total fourths are there?
48.
Yeah.
Which is again, the idea of inverting multiplying, you take
I have the same.
Yeah.
12 things and multiply
Okay.
by 4
12
really easy.
pieces, each slice is
Yeah.
You're just saying how many.
How many total slices?
Are
Yeah.
12.
How many fourths of a pizza?
Right.
Yeah.
It's hard to
So, Renee, did you have something different or is it
And
similar?
especially if you have like
Well,
1/4.
similar in that we all have
1/3 or
one
something like that, so.
whole object that's really interesting. We're just all seeing how many points.
What's that?
Yeah.
Part of my model was always the
Problem one.
Okay.
One-
You use quarters?
Quarters
Okay.
instead of how many quarters are in 12 hours.
Yep.
I have 12
Okay.
things.
So that when you do something like this, is what Dan and I were just talking about. They have to be relative to the same size pool.
No, same
So if
thing.
you
I
have
started with
1/4,
12 tiles, I guess, since we did this. And then I said cut each tile into fourths, and then how many total tiles do you have? And then my everyday application was pizzas. And you cut each pizza into 4 slices, how many total slices do you have?
So then it was
And then you have
When we come
1/3.
back together, Doug, would you share a sense of those?
So you're saying how many factors?
12
is
pounds
this?
and
That.
How many?
Yeah.
There's a whole texture, there's a.
Those are New York style slices,
or
Chicago style.
Chicago
stuff.
Oh, man.
New York is a big one. You just
12
chow it down.
Before they start breaking.
I bet you I could eat 12 pizzas.
taking 12
How about,
and
how about
dividing it into groups.
4 people?
And so,
So what we talked about with Renee and I went to this training was that you could actually take,
sorry.
So if you have.
this is where it gets
So you have two pizza, one pizza that is free.
Here, it's like, oh, it's
Overlap this, over this. Okay, well, it goes down.
Be careful.
It goes into the remainder.
So the farther from the students.
But even the process of cutting each fraction out.
Dividing by fractions.
Yeah, or the big thing we talked about is, a lot of times, to save time,
So
people
then
have
divide
things
by
cut
half,
out every
and
time.
12, then it's now.
But in terms of meaning.
Pizza, slices this big.
New York. If they cut out 1/3, they have a better understanding of what 1/3 is.
Thin slice, about this big.
You know,
How
and
the,
it takes forever, you know.
You've got your number of groups.
I know.
How much is in?
yes. Okay, yeah.
So that, Doug gets in a different approach first.
Nice.
Sure.
Yeah, right.
It is multiplication, that's one, yeah, that's
Wait,
one, that's one foot of time.
All right, I'm gonna bring us back together.
Worth it at that moment.
So, again, appreciate the conversations that you're having, and I get the privilege of dropping in and conferring with people, asking a few questions, making sense of those ideas that are out there, and I want us to have that chance across the group. So I'm gonna ask Doug if he'll get us started. So, Doug, can you talk to us about visual here? Or maybe you can hold
If
up
we
so people
could
can see it. Or...
imagine one row of 12 tiles. We have a 1 by 12
So you have
surface area.
6, 7, 8, 9, 1,
Now you're in trouble.
5, 6, 7, 8, 9, 10,
11,
11, 12. Okay.
12.
So you got 12. You got 12 tiles.
Each of the 12 holes are then divided into fourths with a
So it's kind of like this
horizontal and
idea.
a vertical. Yep. And so on and so on.
Okay. So I did the original tiles in green, hopefully trying to show the original pieces. So your 12 was 12 tiles. Each one
Divided into 4.
divided into fourths. Okay? So what question are you asking at this point then?
Well, my real life, my everyday
Yep.
life was I have 12 apples and we'll cut each into 4 or fourths.
I have 12 apples. 6, 9. Cut them into fourths.
How many pieces will I
Okay. So over here, we're asking then how many fourths do we have, right?
have? Yes.
So in this problem, what is unknown?
How many pieces or how many fourths?
So we don't know how many,
How many fourths are in 12?
yep. Okay. So we don't really know how many groups we have pulled yet.
I get confused when you're using the term groups. I mean, there's a group of 12 there,
Okay, so we had 12 to start with,
okay?
and we broke it into fourths. So how big is each group?
Each,
Say-
how
say
big is
again?
each group?
So
Each group is 4 big.
So, well, so this, we broke it into fourths, so that's one
What is
group.
it?
Yeah.
Are we taking it from groups down to individuals?
I believe so.
We don't know how many individuals, how many, not groups. but
How many 1/4ths are in 12?
Yeah,
Okay.
how many parts?
Individual one.
Yeah, parts and whole. I'm confused by your usage of the term, we don't know how many groups.
Okay, okay, so I appreciate the press, so let's make sure that we're being really clear. So we know that we're looking at each piece as a fourth, and we're looking to find out how many 1/4 pieces
There we go.
are in, okay, are in 12, is essentially what we're asking. Right? So our answer is 48. So that one processed pretty quickly because this particular, so when I stopped at this middle table, just to be transparent, I asked Doug to talk about this, and each person at that middle table had something similar, slightly different context. We had pizza, we had money, but similar to this. So I also saw similar things at the other groups when I came by. I want us to think about how else we could represent that. And I'm going to ask Steve if he'll talk about his example.
All right, Steve, don't be too excited.
So
Contain your excitement.
You want the words?
Sure. So, yeah. So tell us about your example. And I'll try to. I'm going to capture it. I'm going to capture it off to the side.
Okay, so I have, if you just would make 12 hash marks.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
And so I establish a pattern to make a point to get to the answer. And so I start with, if I'm going to divide that by 6, I would be dividing into 6 groups. I would circle.
Okay. So you're deciding how. Okay. So let's think about, again, going back to that idea of groups. So you're deciding.
I'm establishing division is to divide into groups.
Okay.
And so I start off with dividing into 6 groups.
Okay, so we could circle, we could make 6 groups, and we're wondering then.
How many are in each group?
And how many are in each group? Okay. So you basically did.
Goes divide by 6 and divide by 4, divide by 3, divide by 2.
So he was looking at a pattern.
And I
Okay.
get down to divide by 1, and obviously the answer is 12. And so at that point I would stop and I would say, what's the pattern happening here? As we're dividing, what happens as we have less and less groups? And then obviously the contents are getting bigger. And so to establish that when there's fraction, divide by fraction, the number is going to be larger. So then at this point then I draw the 12 hash marks again, and then draw half of a circle around them, because to divide by half means that's half of my group.
So this is
Half.
half of a circle. Okay.
Um,
So if we were to have
Yep.
the other half of the circle, then
Almost all the kids realize there's 12 in that half, and so then the answer is going to be 24.
okay. So now we're getting close to.
We're getting close.
Yep. Nope. Yep. But I appreciate the lead up here. So now you're looking at 12 divided by 1/4.
I would draw the 12 again, draw a circle.
Yeah, I'm going to do it in a different color just to make sure that it kind of stands out. Okay, so you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay,
Okay. So that circle comes around it also.
so now you have kind of one circle, but this is how much of the circle?
Well, it's a fourth of it, obviously. But
So, yeah. So you've got 12 in 1/4.
okay.
Okay.
And you're pretty quick to fill in the 12s and the other fourths. And then you can see that I'm having a 48.
Okay. So what are we looking for here?
We're still, yes, we're just looking for the number in the total group.
Yep. Yes. So I'm thinking, I heard you say 12 in 1/4 of the circle. And say your question again?
How many are in items or whatever we're going to use are in the total group?
Okay. Or how much is in one?
Yeah.
What do you guys think?
I think he's restating the problem as 12 is 1/4. Instead of 12 divided by 1/4.
So rather than looking for how many fourths are in 12, there's 12 in 1/4, so how many are in the whole?
12 is 1/4 of what?
12 is 1/4 of what?
48.
Yes, so everyone. So turn and talk to your partner real quick. I want you to do 2 things with your partner. One, say one thing that you understand about what Steve just had us think about. And once you you each said the thing you understand. If you have a question, make sure you pose that. But then think together, how could you depict that in an everyday life situation? This idea of there's 12 in 1/4.
That pattern finding, some kids don't understand the interactions, that they're bigger numbers, because you're sharing with fewer people. And so sometimes it does help to see, I'm not saying, you might say, a middle school is one strategy to solve this problem. You're learning this concept, yes, but.
Except there might be some problem.
Of the flat.
Okay.
I'll kill everybody.
Cameo.
I'll kill everybody.
Cameo.
How about,
You guys have or you might, what life, everyday life, is kind of like,
Yeah,
okay,
still
so
try the same.
give me a second to think about that.
activity that costs.
I would see if you would have to cut out traction strips.
You say, I was, you
You
had
want an
an
example? Okay, yeah, so tell me your example, or where you are right now.
It sounded like it's gonna.
Okay, so how about like, you have, good segue, constants, so we're at, how many common size have granola bars? There's 4 boxes, or cereal, whatever, 4 boxes of milk. Let's go with granola bars. So 4 boxes of granola bars in this big batch, and then 1 box has 12 granola bars in it. So then how many are in total?
Something smaller than one.
But I think that it's part of
It does, so think about that. So there's 4 boxes in there, how much of the entire package is 1 box?
That's
1/4, yeah. So there's 12 granola bars in 1/4 of the entire box.
Entire box, how many is there?
How much is in the big box? Yeah, absolutely.
Yeah, so that's just the main course, or like, what if,
You can,
we're trying to figure out.
It's not the path that
Absolutely. So it could be that people actually see it, and some kids might see that as a division problem, but it also then helps make that, yes, yeah. So then, the extension question would be, thinking about division. Yes. Because there is a generalization that we want.
No, you're not dividing by 4.
You're dividing by
One is,
fraction.
this is
What is it and why is it? So that we don't get kids that are racing, and then all of a sudden they're playing 12 rules everywhere.
Why'd you do this? Because.
All right, I'm gonna pull us back together.
Lots of ways you can use it.
Oh, right. I think it's so important.
So I would ask Kyle if he will share, and I'm gonna try to capture his thinking here. So, he went to Costco. Okay?
Started.
Yep, executive member.
Fantastic. So at
Okay, so at
Costco,
Costco, buy this big pack of granola bars. And on the big pack,
buying granola bars.
4-pack.
a 4-pack, okay,
Okay.
4-pack of granola bars.
Okay, so
All
you're,
right, and so, and then in 1 pack, there is 12 granola bars. How many are in the entire box? I don't know.
yeah, so
So
let's
it's a
think about these
4-pack.
pieces.
That has
12 separate granola
packs,
bars.
and how many are in the box?
Okay, so there, say it again, there
So it's a
are
4-pack.
12
Bars.
bars in 1/4
In 1/4 of the box,
of the
or
box.
package.
Okay.
Are they all honey and oats?
There's some oatmeal raisins, you don't know.
So what's our question that we're looking for here?
How many
Are
total
in,
bars in the whole
how many are in the
whole box?
entire box?
Yeah.
Nice. Okay. So again, you kind
I
of
think
called
the
out.
question that came up at our table is
Yeah.
that I think a student would more look
just to do 12 times 4 instead of.
Ah, so that was one of
Yeah.
Renee's
We
observations.
think that is conceptual understanding of inverting and multiplying, and we
Yep.
think that's more conceptual understanding of grouping into smaller.
Okay.
Yeah.
So again, so Renee mentioned the same thing, that she thought that thinking about this problem or thinking about it this way might do what?
Might be the segue into why we.
Invert and multiply.
Yep, absolutely. So thinking about that understanding, we want to build that understanding, and it could be in looking at it two different ways. It could be looking at this pattern and thinking about what's happening when we're dividing. In lots of ways to actually segue to that piece. But helping kids understand what's happening and why it works, that conceptual understanding, that meaning of what's happening, so that when they have this rule, invert and multiply, that they actually understand what they're doing. And I asked the question over this table, do you ever get kids who just apply a rule anywhere? Maybe you're inverting the first fraction, maybe just change it to multiplication and don't flip anything over. I mean, there's all kinds of things that kids will do, or both. And sometimes that comes about because they know there's a rule, but they don't understand the rule. So thinking about how do we help kids make sense of it so that they can be efficient. Because if we as mathematicians sat down and we were going to divide fractions, how many of us would change it to a multiplication problem and invert the second one? Probably every one of us. We can do that because we understand why. And that's what we want for our kids. That was kind of a funny laugh.
Maybe not everyone understands it,
Yeah.
but still able to be successful.
So, okay, so and if that's the case, so here's a point for a little self-reflection. If that's the case, what might you want to ask either now or ask your colleagues when you're doing math with them to help make sure that you do have that deep understanding? Because it's really hard to help kids develop an understanding if we're still a little soft, right? So again, being reflective, if you're not quite sure why a rule works, please ask your colleagues, and hopefully that community is a safe community, just like we're trying to build in our classroom, so we can do math together and press on each other the same way we want to press on kids. Absolutely. Okay. So again, thank you for taking a few minutes to kind of think about those two specific problems there. I'm going to ask us to come here. And I'll move that paper, it's kind of in the way. Sorry about that. Now that I'm done writing, I'll stick it on the bottom. So there's a string of problems up there now. I want you to think for just a couple minutes here. How are those problems alike? How are they different? What regularity are you noticing? And what conjectures or generalizations might you make and be able to justify? And again, let's take just a moment here, private reasoning time. And then I'll have you talk with a partner. So just a minute or so private reasoning time. So I'm going to have you check in with your partner or your table group. I'm going to let you decide at this point. What I would ask you to do is to pay close attention to airtime. Is everybody in your partnership or your team having an opportunity to share their thinking? If somebody's being quiet, please ask them to share their thinking so that we get all voices out. But I'm going to let you monitor that this time. How are these problems alike? How are they different? Might be something that you see that's pretty straightforward. Might be something you're kind of digging a little bit into. What regularity are you noticing? So if you were to solve these, what might be happening? Which can help lead to what conjectures or generalizations might you make and be able to justify. Okay. I'll let you check in with your partner or your table group. Make sure you're checking airtime, that everybody has an opportunity to share.
Is there any secret behind these? You're what? Oh, so it was a pattern and stuff.
I didn't know the order. I think I can see.
Yeah, well, the biggest whole number, the small.
So that'll be your generalization. Figure out the answer by multiplying.
Lo and behold,
Because my picture right here that I did before. form. I mean, you're right, yeah, I mean, yeah. If I-
That's how I see it.
Oh, no. Absolutely, I'll bring you chocolate, it was a great transition. Love it.
Oh,
Oh, you did, you said something, it's not procedural. What do you guys think? What conjectures or generalizations might be coming to mind?
That's fine.
Could you justify that that would be true? So is that true with any situation that I might give you? If it- Okay, so you're narrowing the scope a little bit.
Yep.
Okay.
We want you to focus on the third question.
That's all I can do.
Is that what you call it?
So what if it was 3 divided by 2?
How might you justify that? How would you convince
If you're dividing by 4, you're saying that this is a fourth group.
Could you do that?
Yeah, I'm
So if you got half
asking
hours,
questions, I want to prompt that thinking.
that's 1/4.
See, that doesn't mean I only one way to do it.
Otherwise, we just.
Absolutely could.
Because it's
We're not
practical.
gonna represent
Kids do the same thing. Go do this, I will give them one in the hands and I just create them.
All right, I'm gonna pull us back together.
$5 for one house.
Probably needs 7 gigabytes though.
Let's think about these questions, and at least for these first few, let's just popcorn out a few ideas. So,
Terrible.
how are these problems alike and how are they different?
They each have a whole number and a unit fraction.
Okay, so they each have a whole number and they each have a unit fraction, okay? So that's a similarity. How might they be different?
Different fractions, different numbers.
Okay, so they might be, we could say that they're different whole numbers and they're different unit fractions. And again, that's just the kind of, thinking about this, the questions that we might ask students in our classroom, getting them to pay attention to what's happening and what patterns might be going on there is really important, because if we want them to notice something, they might have to think about some of those first pieces. How are they the same? How are they different? To get at this next one. So what regularity are you noticing? Or what patterns are you noticing? And Jason, will you share your piece?
I just said that all the answers would be bigger than the number that we started with.
Okay, so all of the answers would be bigger than the number that we started with. So I want you to think with me for a minute. We're back in the classroom. You guys are students. Jason just said this in our classroom. What questions might I ask him at this point?
Prove it.
Prove it, okay? So what else might I ask him?
With 3 halves work.
Okay, so I might ask, would 3 halves work? Okay? And again, I might ask that if I want to start moving away from this string. Going back to the prove it. Okay? So I might ask, in fact, I did ask him, how might you justify that? And what would you want students to say? So if you guys were students and I had waved this magic wand and you were all going to say exactly what I wanted you to say in terms of showing understanding of that question, what's going to happen? What are you going to say? How could you justify that?
Use the models that we did.
Sure. Absolutely. Yeah, we could come back and we could use the model. So we've shown this with that top one. We might have to do a couple more in order to be able to show that it's continuing to happen. And then I might move to a question like what Steve asked in terms of when would that be true? Or would it always be true? And again, that's getting to those generalizations. So let's think about that. Would my solution always be larger than my initial value? If so, why? If not always, when is that true?
You want an answer?
Let's brainstorm a few
As
ideas.
long as the fraction's less than 1.
Ah,
Yeah.
okay. Okay, so there's a piece. So if my first value was a whole number, so let's start with that. And my second number was less than 1, a fraction less than 1. Then the claim would be that that would always be true. What do you guys think?
Yes.
Okay, so now we've got a specific case there, whole number divided by a fraction less than 1. When else might that be true? Or when might not it be true? Okay, I hear, you want to share that? Share that piece.
X is greater than 0 and X is less than 1.
Okay, so we're looking at, in this case, we're looking at a value between 0 and 1.
0.
Okay?
The first number can't be negative.
Okay, so what would happen if the first number was negative?
Opposite would be true.
So that changes the conjecture, right?
Smaller, yeah.
So the original conjecture was if the first number is a whole number and the second fraction is a fraction greater than one, less than 1,
Greater than 0.
but greater than 0. Okay, so we're tightening up the language around that conjecture. And then you want to, depending on what your core math idea is and where you wanted to take the students, you might then start thinking about what happens when one of the values is a negative number. You might start thinking about situations where the fraction could be greater than 1. You might be thinking about situations where it's not a whole number as the first value, that you've got either another fraction is greater than 1. There's all kinds of scenarios we could go down. So thinking about those generalizations, if we were working with the string of problems and we're working with students who are learning to divide fractions, and they say, oh, that number, the answer is always going to be bigger. Yes, but what's the constraint on it? So getting excited that they've seen this generalization, that they're making these conjecture, but then helping them realize the context or the constraints that they're working within at that point. That it might not always be true, but right now it is. Other generalizations or conjectures. Something you're thinking that might be true of this string of problems.
Well, if you take the second fraction and invert it, turn it over, and then when you multiply, you get the same.
Okay, so when I walked by this table, so Steve, I'm glad you brought that up. I heard a couple people say, well, you could just multiply the denominator by that whole number to get the answer. Okay? So again, thinking about what Renee said, that this conversation about the meaning of division could slide into understanding that rule. So is that always true? Can I always just take my first value and multiply by the denominator?
Only when the numerator is 1.
Okay, so in this case, if I was a student who's saying that, you're going to help me think about that's true when when the numerator is 1. Because then you might also then want to go on to, well, what happens when the denominator is not 1? Maybe the same lesson, may not be the same lesson. Would that hold true if my first value was not a whole number? So Steve's conjecture was I can take my first number and multiply it by the denominator of the second value, which in this case is a unit fraction. Would that conjecture hold true if my first value wasn't a whole number? But let's say it's still positive.
So like, what if you 2 1/2, it would still work.
Okay, so if this was 2 1/2,
Yeah.
I could take,
It is a whole, it's a whole number and a fraction.
what if this was 3/4?
Yep. As long as it's still positive.
Okay, yeah, because
Or
then
greater than 0.
okay, so we're thinking greater than 0. Again, once we get into the positive and negative numbers, then we have a little different constraint that we're dealing with.
Numerator's still 1.
As long as your numerator remains 1. So again, those pieces that we're talking about here, those conjectures or generalizations, and thinking about how we want that for students. We want them to have that understanding. We want them to know how to do this in an efficient way with understanding. Because what we don't want is for something like this to slide by, and then tomorrow when they walk in, they're just saying, oh, it's 2 multiplied by 1/6. Or it's 1/2 multiplied by 1/6. Because they're going, oh, there was a rule to that. And they start doing funny things with it because they don't understand connection. And again, that pressed for being able to justify it. So the very first time I pressed, and we said we could come back to some of our pictures. There was
I think
some.
where this really starts to the rule, whether they understand it a lot, is when they're solving equations with fractions.
Yep. Mm-hmm.
Because you know, when you start to see that, and they always do the inverse of the. So they always think the second number, you know, because that's what they hear all the time.
Yep.
When they're doing an equation, they always do not the actual. They do the. I'm trying to put this in the right words, but they do the fraction that you're actually solving instead of the second.
So if it was something equal to a fraction, that you might see them invert the solution actually there.
Yes.
Yeah? And again, they're probably doing it because they know they need to do something about invert and multiply. But thinking about how do we build that conceptual understanding and that understanding of what's happening when we're dividing so that they can do that in an efficient way. So I want to call out the fact that at this point we're really thinking about those generalizations. We've gone from a single problem to kind of a string of problems and then thinking about what is always true and what is sometimes true. And when you think about when is it sometimes true, what are the constraints that enclose when it can be true? And we did that, or some of that has been done, by looking at some of that regularity in the patterns. So thinking about a string of problems, looking for those patterns, and then thinking about what's always true. Questions, comments, thoughts on how we might have been using the habits of mind and habits of interaction? I called out two that I wanted to bring attention to. Others that you want to think about. So this one down here doesn't have a flag on it. Math reasoning is the authority. Have we been doing that?
That's what we say to the English teachers.
Okay. Has math reasoning been the authority here? Or has someone been right just because they said it?
We've had to model and represent this in order to show that it's the fact.
Mhm.
Proving it.
Yeah, going back to that justification, absolutely. And we've been using those mathematical representations to do that. So I think about this, and maybe not so much here, as a group of colleagues, but thinking about in the classroom. Do you ever have students who will say, well, Matt's right, because Matt said it. It's all about Matt's status.
I've never heard anybody say that.
Okay, so you've heard
It's
somebody
about
say that.
himself. I get the, it's right because the calculator said it.
Yes, okay, so sometimes you get it because the calculator told me that.
I just respond with, don't ever trust robots.
Okay, right, well, because it's basically a little computer, garbage in, garbage out.
Right.
Yeah. So you hear the calculator said it's right, or so-and-so in the classroom said it, because, everybody knows that that person knows what they're doing.
Yeah.
Or they'll say, well, my teacher told me.
Yeah, or that, yeah. Just
Yep.
because I put it up there doesn't mean someone's right.
Yep. And if they say that, and then you come back with, well, why does that make sense, or how do you know? I think about that press that we want math, reason to be authority. We don't want somebody or something to be the authority. We want the kids to have the ability to reason through and make sense of why it works.
Mm-hmm.
That doesn't mean they have to do it on their own. We have partners, we're working together, you're there to facilitate the learning, but that in the end, they have mathematical reasoning to be able to say why something does or doesn't work.
Yeah, I kind of foster that with the following day from a previous lesson, the homework check.
Mm-hmm.
So putting up the answers, the first few times of just putting up the answers, the kids would check their answers, right? And so then I started throwing in wrong answers.
Yeah.
And so I'd have kids be like, oh, what? Why do you get that? And so then they erase it. And then I'd say, anybody have any questions? And no questions. That's the first couple times. So then I was like, okay, any questions? And so finally someone said, well, I got something different there. So I said, no, what? That's the answer. No way, let's talk through it. So we talked through it. They're like, why are you wrong, Tate? I was like, well, maybe because I want you to learn that to trust yourself, and you maybe, and so it was kind of cool.
Yeah. Absolutely, and so I want to think just for a minute about that strategy of putting out a wrong idea or a mistake as a point to make sense of.
Yeah.
You could do it through homework. You could also do it as you're monitoring your class. So if I see, the same misconception in a variety of places, I might grab that misconception and slide it out there and ask the kids, will this work?
Yeah.
May or may not be in the kid's handwriting. I might write it on a piece of paper and then slide it underneath. It all depends on the mistake, all depends on the students, all depends on the culture of my classroom. Or I might slide that misconception and a correct one underneath my document camera and say to the kids, which one is right and how do you know? Because we want this and this. Yeah. So but thinking about how you can use that strategy where a mistake or a stuck point really then becomes a launching point, for some learning. Yeah. Steve.
Sometimes I'm going around the room, I'll stop and ask a kid how they got an answer, and
Yeah.
if they can't tell me how they got it right away, I'll say, well, I'll bet you $1. And then challenge them that if it's right or not. And occasionally, sometimes the kid will be right, because I always bet kids just to get money and lose my job. But to get them to start.
This is on video, right?
Yes, we have documentation.
But to start getting them to have a reason for why something is right.
The metaphorical.
Monopoly money.
For $10, I'll get it off the video for you.
That's on video too.
This is pretty
On one of my little 8-question quizzes, on one of them, I had all 4 of the answers were incorrect.
Ah.
So I told them